Okay, good day. Today we are going over Algebra 2, Lesson 10.8, Exponential Equations, and you'll be able to use log properties to solve exponential equations. And as you all know from our live lesson, this supports Delta Math assignment 10.8 on exponential equations. And so going back over what we started out, and I had indicated to you, a lot of people ask, well, what are log equations for? And frankly, sometimes it's really difficult to understand why on earth they what's the purpose of a log equation. And really one of the big purposes of a log equation is to be able to help you solve exponential equations. And so let me just give you an example. This is a typical exponential equation that you see here. And all of you know that if you can get the bases the same on each side of the equation, then what you can do is throw away the bases and solve the equation using the exponents only. So that's from the one-to-one. Remember, we had the one-to-one video and lesson, and it says if b to the u equals b to the v, then the exponents u equals v. So you get the bases the same and you're in good shape. So let's just do this. We're going to, over here on the left, we have a base of 2, and that's a prime number, and 2 is that's all you're going to get for base. So over here with 16, if you factor 16, you get 2 times 2 is 4, times 2 is 8, times 2 is 16. So that's 2 to the 4th. So if I were to rewrite this as 2 to the 4, then, and it's the base, not the x. Let's not include the x here. Then what I can do is multiply the exponent, x minus 3 times the 4, and revise the exponent so that we take into account that the bases are going to be the same. So we have 2 to the x over on the left equals 2 to the 4 times x minus 3. So let's just distribute the 4 to the x and the 4 to the negative 3. And so you have 2 to the x equals 2 to the 4 times x is 4x. 4 times negative 3 is negative 12. And then you just throw out the 2's and rewrite this as x. Let me move this up here, and let me move this down. X equals 4x minus 12, which is a simple linear equation. You want to get the x's together, so you're going to subtract the left x, and that's going to leave you with 0 equals 3x minus 12. Then add the 12 to both sides. You get 12 equals 3x, and of course divide by 3, and you get x equals 4. Okay? Because 12 divided by 3 is 4. So that's fine. But now, what if we can't match the bases? So what if we can't make the bases match? That's the conundrum that we have with exponential function. And frankly, it's solved by logs. So here's an example. 2 to the x equals 5. Both 2 and 5 are they are prime numbers, those are going to be different bases. There's no way that you could solve them using this method that we got here. So this is the big question, and it's solved by logs. So this is solved using logs. Okay? All right. So let's start with our first one. And so again, we're going to solve for x and round to the nearest hundredth. So these are exponential equations if you look at them. How do I know that? It's because the exponent contains an x with both of these. So over here, the first thing you're going to do is you're going to want to get the base and the exponent of each of these exponential functions isolated. So the first thing we're going to do is isolate b to the x, which is the base to an exponent, right? And so, and I'll just even highlight that just to make it clear. And so over here, I've got 602 multiplied to the base of e to the x. So I'm going to divide both sides by, let's use a pencil, by 602. And of course, the 602 divided by 602 cancels on the left. And that leaves me with e to the x equals 86 divided by 602. Now, what we're going to do is what we talked about when we were dealing with log properties previously, is where we've got two different bases here, which we do, we are going to multiply both of these sides by a log, natural log, because that's the simplest thing. We've got an e here, that's a natural log situation, and it's just easiest to use natural logs for these. So I'm going to multiply both sides by natural logs. So multiply both sides, both sides by ln, okay? So I'm going to multiply this side times ln and this side times ln. Now when I do that, why do I want to do that? It's because, first of all, it allows me to drop the exponent. That's really the big thing. It allows me to drop the exponent down in front where I can multiply it to the rest of the equation. And so that's really what we don't want to do. That's the goal here. But like I said, you do one side and then you do the other, but then the exponent is all by itself on the left-hand side. There isn't an exponent over here. So this is kind of like simplifying over on this left-hand side, okay? So when I rewrite this, it'll look like this. Exponent times natural log of e, and of course the x is moved down, equals the natural log of 86 over 602. Okay? And this is a multiplication problem. Okay? Everything's multiplied across. All right. So now what I want to do is I want to get rid of the natural log, if I can, and get x by itself. So what I would have to do is divide. I want to divide all this by the log of e, which is natural log, right? Log of e, natural log of e. And when I do that, this becomes natural log of e times e. And when you do that, it cancels out. All right? So anyway, you end up with x all by itself, and that's the goal. X equals the natural log of 86 divided by 602. And that's an exact answer. Okay? So this is an exact answer. And like I said to you in my live performance of this exact answer is like a fraction, like the fraction 1/3. That's an exact answer. But if you set it up as a decimal, it's going to be 0.33333 on into infinity. It's not an exact answer then. But in fact, what we do when we have a natural log and we want to find out a math answer, we just go ahead and put it into our calculator. So let me clear this and type. I'm going to type natural log down here. There it is. Natural log. And then I'm going to put in 86 divided by 602. And I get negative 1.945, which is approximately negative 1.95. So I'm going to write that. X equals, or X is approximately rather, negative 1.95. Okay? And we said round to the nearest hundredth, and that's what we're doing here. Okay? All right. Same kind of situation here. We just did different problem. So we're going to divide by 97 to get rid of that on the left, and now I have the base of 2 with an exponent of 2x, and that equals 69 over 97. And then multiply both sides times the natural log. So again, why am I doing it? I want to get this power down. Okay? So it's going to go down here. That's where we're going to put it. So we're going to end up with 2x, that's the exponent that's dropped, times the natural log of 2, and that equals the natural log of 69 over 97. Right? Now, I want to get the x by itself, and to do that, all I really need to do is get rid of the 2, the natural log, and the 2. And I can do that to both sides. I can divide both sides by all of that, because remember, this whole thing is a multiplication problem. It's 2 times x times the natural log times 2. Okay? So I can divide by 2 times natural log of 2, and I'm left with the x. I'm going to divide over here, 2 times natural log times 2. Okay? And so now I have left x, and that's going to equal the natural log of 69 divided by 97 divided by 2 times the natural log of 2. Now all of this is a number. This is all a number now. There's no exponent, there's no variables in it. The x is over here, that's the variable. So this is an exact answer. Okay? So let's just go ahead and find out approximately what this is. I can put this in the calculator now. So I'm going to type again natural log. Let me lighten this up a little bit here. And let's put the light on, see if that helps. Okay, so clear this. So I'm going to click the natural log button. And now you'll notice I've got this all in a fraction. So I'm going to do the natural log of this divided by the natural log of the denominator. So natural log of the numerator divided by the natural log of the denominator. So in the numerator, I'm going to put 69 divided by 97 in the natural log parentheses, and then I'm going to hit divide. And then I'm going to go and type in 2 natural log of 2. So 2 natural log, put in parentheses the 2, close it, and hit enter. And whoops, let's see, I think I missed a. Okay, I need to do parentheses in the denominator. So let's do that one more time. So what I'm going to do is put a 2 in parentheses and natural log of 2 in parentheses in the denominator. So I'm going to rewrite this as natural log of 69 divided by 97, close the parentheses, do the divide, and then parentheses 2, close parentheses, and then natural log of 2, close the parentheses. I think that'll work. No, it wants me to put a parentheses around the whole thing. So I got to put parentheses around the whole thing. Sometimes it does this. This is an older TI-84, and you end up having to throw more parentheses around things. So let's clear it. And again, we're going to type natural log of 69 divided by 97, and then close the parentheses, put a division sign, and then the argument, argument parentheses, and parentheses 2 and parentheses, and then times, so parentheses, natural log of 2, close parentheses, close argument parentheses, hit enter. Now we get it right. So negative 0.25 is what we get approximately. Okay. So be careful. Make sure you have an outer argument parentheses, and then make sure you've got the operations using parentheses when you're doing this. And then, of course, the natural log is just itself. So we've got that taken care of. Now, let's go on. So with this next problem, we have a fractional exponent, or sometimes called a rational exponent, in an exponential function. Okay? So let's put my calculator over here, and we first of all want to get the base and the fractional exponent by itself, because we want to drop that fractional exponent out front. So I'm going to divide, if we need to, that is, but we will see. We're going to divide both sides by 43 then to get the base and the exponent isolated. And so when I do that, of course, the 43 and the divided by 43 cancel, because that's 1, and you're left with e to the x over 5. And that equals, and then 430 divided by 43, that's just 10. If you need to do a calculator, I use a calculator to figure that out, do it. But it is 10. Okay, now I want to move the power down, but to do that I have to have the natural logs multiplied to each problem to allow me to drop it down. So I'm multiplying times the natural log. So I end up with, and then I can drop the exponent down here. Okay, and it will multiply to the natural log. So I'll end up with x over 5 times the natural log times e. Okay, and then that equals the natural log times 10. Okay, So now that I've done that, I want to get the x by itself. The first thing I got to do is get rid of the 5 in the denominator here. And the way you do that is multiply times 5 over 1. So multiply both sides times 5 over 1. And so we're going to do that, and let's just rewrite this. I just was thinking how I wanted to do this. I'm going to write it like this: 5 times x over 5 times the natural log of e equals natural log of 10. All right, so then the 5 and the 5 cancel, and then you have x times the natural log of e. Now the interesting thing about this is the natural log of e. That's the same as, so a natural log of e, or natural log is the same as the log of e, right? So really what I have here with the natural log of e is I've got the log of e to the e to the, well, e to the what? Well, okay, this is your base. E to the what equals e. Well, e divided by e is 1, so this has got to be 1. Okay? So e to the 1 gives you e. So think of it that way. What power would give you a e, the base of e, if its output was e? Okay? And you know that e to the 0 is 1, but e to the 1 is e, and that's what we're getting here in this little circular thing that we're doing. So, having gone through all that, then you know that you're left with this canceling. This becomes 1, okay? Because that's what the answer is. And so I have x to the 1, or x, equals, oh, I forgot that I had the 5 over here. What I did to one side, I had to do to the other. So I've got 5 multiplied to this side. So I have 5 times the log of a natural log of 10. Okay. Now this is again the exact answer. I want to find the natural. I'm sorry, the decimal version. So it's approximately. Take my calculator. And this one's simpler to do. Let's see, we have 5 times the natural log, okay, and then put in 10. And hit enter, and you get approximately 11.51, okay? So you're going to write 11.51. Because we're doing it to the nearest hundredth. Okay? All right, let's look at the next one. So the next one, I've got 0.02 equals 1.075 to the x minus 3 minus 3. Now, you notice I've got an exponent only over here. I need to get natural log to get it down. So really the first thing I can do here, this is by itself, except for the negative 3. I'm going to have to add the 3 to both sides. So let's do that. So I'm going to add 3 to both sides. And let's see, negative 0.2 and 3 is 2.8. So I'm going to rewrite this as 2.8. Let's put a line under each of these. 2.8. And that's going to equal 1 point, and let's move this over just a little bit. Give me myself some space to put in my natural log. So, and let's make that equal sign a little clearer. So 1.075 to the x minus 3. Okay, and that, of course, is gone. So now I'm going to drop my natural logs in. So I'm going to go and multiply 2.8 times the natural log and the right-hand side 1.075 to the x minus 3 times the natural log. And then that allows me, of course, to then drop my exponent down. I didn't leave me much room, but I'm going to be doing that down at the bottom. So now I've got the natural log times 2.8, and that equals, now I'm going to bring down the x minus 3, I'm going to put it in parentheses because it's a binomial and I'm multiplying it, times the natural log of 1.075. Okay? So if you look at this, over on the right-hand side, this is all a number except for the x. And so we want to get that x by itself. So what we're going to have to do is divide everything here on this side and on this side, left and right, by the natural log of 1.075, because that is a number. Why? Because, again, natural logs are numbers. Remember, e is a little less than 3. So I'm going to divide by natural log times 1.075. I'll put that in parentheses. And I'm going to do the same thing over here, natural log times 1.075. And when I do that, this cancels, and now I have x minus 3 by itself, so I'm going to rewrite this as natural log of 2.8 divided by the natural log of 1.075, and that's going to equal x minus 3. So what I want to do is add 3 now, because I want to get x by itself. Add 3 to both sides. Add 3 here. I'm going to add 3 over here. And I'll put it over here to the right. So I'm going to rewrite this as the natural log of 2.8 divided by the natural log of 1.075 plus 3 equals, and of course, x, or 3 and negative 3 cancel, and x is by itself. So now this is all a number. I can put this into my calculator. It's going to be a little wonky because I got a lot of stuff here. So let's see. I think I'm going to have to, this I can leave in the numerator by itself. Oh, but I'm going to have to put a parentheses around all of this and then add the 3 to the end. Okay? So that's what I'm going to do. So I'm going to type in, let's move this over a little. I'm going to type in, again, the natural log of the numerator. Got to turn this on one more time, clear. Natural log, and then I'm going to put in 2.8. Oops, I forgot the parentheses. So I'm going to put in parentheses, then natural log of 2.8 in the numerator, close the natural log, and then divide it by the natural log of 1.075. 1.075. Close that, parentheses, and then close the argument parentheses, and then add all of that argument to 3. And what do I get? And it looks like 17.24 approximately. Okay, let's bring this down. Okay, so the answer is 17.24 is approximately x. Okay, and again, remember, this is your exact answer. By the way, I should have put a little parentheses around the back part of 1.075 on the left side. And that's everything for this particular problem. Okay, let's move on. Okay, another log problem. Doesn't look too difficult just to look at it. Let's just go ahead and do it. So we need to, let's throw it on, we want to drop down the exponent, so let's throw a natural log down on each side. So I'm going to rewrite this as the natural log of 2, put it in parentheses I guess, equals the natural log of 4 to the 4x plus 4. And of course, by doing the natural logs, I can drop the exponent now down in front. So I'll rewrite this now. On the left, it'll be natural log of 2 equals 4x, so it's plus 5, I'm sorry, 4x plus 5. Let me rewrite that. So 4x plus 5, oops, did I? Yeah. And then the natural log, so times the natural log of 4. Okay? All right. So I want to get the x by itself. I have to get rid of the natural log, so I divide by the natural log of 4 on both sides. Oops. This is why I use lots of erasure. Okay. So by doing that, I can get rid of these, and now I have the natural log 2 divided by the natural log of 4, and that equals 4x plus 5. All right, now we can get rid of the 5, subtract 5 from both sides. Let's do it in red. Subtract 5. And so I'm going to have now the natural log 2 divided by the natural log of 4 minus 5, and that equals 4x. Now I've got to divide by 4. Let me move this over. Sorry, I got it far out here. Okay, let's let you see this for a second. I think I was working off the page here. Okay. So that's where I am so far. I'm going to divide by 4 now. And I've got to divide the whole thing here by 4. Okay. And so now, this is all one big number, right? So I'm just going to leave it like this right now. And we're going to figure out what x is approximately. So x is approximately, now we're going to take all of this. Ooh, this is ugly looking. So I first have this that I also have to put into a parentheses to include the -5. Then I do the divide, and then I do the 4. Okay? That's how I will tackle this. So, let's turn this on. Let's clear, and I'm going to put in a parentheses for the outer argument, and then a new parentheses for the 2 logs. So now I'm going to put in the natural log of 2, close that little parentheses, divided by the natural log of 4, close that little parentheses, close the parentheses for the entire pair of logs, then subtract the 5, close the outer argument parentheses, and then divide by 4. Keep your fingers crossed. Let's see what happens. That's what it looks like. Okay. Now I'm going to hit enter. Ooh, scary. I did it right. Okay, because I've obviously checked this before. So it's negative 1.125. So we're going to go over here and write that in. So it's approximately negative 1.25. Okay. All right. Now, some of you may have been saying, in your minds, I know a few of you who would do this. Well, wait a second. Can't I get these bases the same? Well, yeah. So we could rewrite the bases. Right? We could rewrite the bases. Let me bring that down. And so I could rewrite this as 2 to the 1 equals, and then this would be 4 is of course 2 squared, so 2 squared to the 4x minus 5, or 4x plus 5, I'm sorry, 4x plus 5. Right? And then of course I have to multiply the 2 to the 4x and the 2 to the 5. So I can rewrite this as 2 to the 1 equals 2 to the 2 times 4 is 8x, and plus 2 times 5 is 10. Now I can throw away the bases. Bases match. Right? So since the bases match, throw them away. And use the exponents, right, for your equation. So we don't have to do a natural log with this. We just write 1 equals 8x plus 10. Solve for x. Subtract 10 from both sides. So we get negative 9 equals 8x. Divide by 8 on both sides. Now I got negative 9 over 8. What's negative 9 over 8? Get your calculator out. This is easy. Negative, let's clear this. Negative 9 divided by 8. Enter. Oh, negative 1.125. I hit enter twice. Pardon me. I don't know if I can do that again, but I'm going to just divide it by. I probably couldn't repeat that. Okay, negative 1.125. So that's the same answer. So x is approximately negative 1.125. So the whole point to this being is you could go either way. Sometimes you get a choice, and do what's easiest. You know, if you want to, you know, drop a log like we've been doing over here, that's fine. But okay. Okay, now we're going to do some word problems before we go with this. So here we've got. Well, let's just read this. Element X decays radioactively with a half-life of 11 minutes. And let's circle that. Half-life of 11 minutes. And if there are 820 grams, so that's important, of element X, how long to the nearest tenth of a minute, okay, would it take the element to decay to 18 grams? All right. So this is a typical exponential function. And the formula for this would be y equals a times b to the x, but what we've got here is a half-life, and so this is going to be our h down here. So this is our h. That means half-life. And t is time, okay? How long? So how long is time? And they want to know how long to the nearest tenth. So if this is time, this is what we're looking for. So you're going to find t. Okay, that's what you're looking for. And then 820 grams, that's going to be your original amount. Okay, so that's your starting point. And you always use A. So start and with A. So that's what this is. And then the 18 grams is going to be your result. Okay, that's going to be your Y, your result. Okay, so we can just start filling this in. We got 18 grams for the result. That's our Y. Our A is 820 grams times 0.5 to the T, that's our unknown we're trying to find, and then our half-life is 11, so T over 11. Okay. Now, we want to get that T by itself. Okay, so we're going to divide by 820 first. Let's just use red. So we're going to end up with 818 divided by 820 equals, this cancels here, and so 0.5 times t to the 11. Okay, we want to get the power down, so to do that we're going to have to put in logs. So we're going to put in a log on each side. All right? And that way we can drop the power down, right? So we're going to rewrite this as the natural log of 18 divided by 820 equals, and this would be t divided by 11 times times the natural log and times 0.5. Okay. Let's see if I wrote this down. Okay, so now we want to get the t to the 11 by itself, so we want to get rid of the natural log of 0.5. So we're going to divide both sides times the natural log of 0.5. And when we do that, of course, we can cancel this here. And so now we have this, which is now a number, natural log of 18 divided by 820 divided by the natural log of 0.5, and that equals t over 11. Let's make my equal sign a little better. Equals t divided by 11. Now we don't need the parentheses anymore, or do we? No, because we forgot the natural log. Oh yeah, we canceled all that out. It's all canceled out. Okay, so t over 11, t divided by 11. So we'll just write it as t divided by 11. Okay, so now just multiply both sides times 11. And we're left with this number equals, this cancels out, t. So all I have to do is take my calculator now and figure out approximately what t is, because all of this is now a number. Remember, this is an 11. I wrote it really sloppy. Okay. So t is going to be approximately whatever's in here. So again, use my calculator, turn this on, clear it. So I have this natural log up here, and I can just write that by itself, divided by this one, and then multiply it times 11. So I need to start out with 11, and then I'm going to multiply, and then inside that I'm going to put the natural log of 18 divided by 820, close the natural log, and then divided by the natural log of 0.5, close that, and then close the argument. And let's keep our fingers crossed. And yes, okay. So it's approximately, and this is to the nearest tenth of a minute, so 60.6. It's approximately 60.6 is our answer. Okay. Make sure you can see all that. All right. All right. So the idea is you get this all into natural logs, and you can put it in the calculator. If you have an exponent still tied to it, you can't. So you want to get to that point, and then you can put it in the calculator, and you're good. Okay, here's another one. Okay, let me bring this down. Person's investing 10,000 smackaroos, $10,000 in a bank. The bank pays 4.75% interest. Let's put this over here. Compounded semi-annually. Okay, so let's start marking this up. So we start out with $10,000, and since this is interest, this is principal here. So this is going to be principal. Okay, and let me get something a little darker. And then the bank pays a rate of 4.75% interest. So remember, with rates, you have to change them to decimals. So you got to move over the decimal point. So this is going to be 0.0475. Okay, so always remember to do that. And then it's compounded semi-annually, and so that's your n here. So n equals 2. Okay, and then to the nearest tenth of a dollar again, how long must the person leave the money in the bank until it reaches $19,200? So this is going to be the result. Okay, that's what this is here. So how long again? So t for time is how long. Find t. Okay, so let's start plugging in these values. So we have 19,200 is the result we want. And that's going to equal the beginning amount, which is the principal. That's the 10,000 bucks. Times, and then it's 1 plus rate. The rate is 0.0475. Divided by n. Remember, n is the number of times that you compound, so that's 2. And then to the nt, so 2 is the n, and then times t. Now we want to find t. Now obviously this is the compounding interest formula. That's what this is. Okay, so now that we've got this, we just need to go ahead and solve it. I want to get that t by itself. This is the base, this is the exponent. So this is my a. I got to divide everything by $10,000. So I'm going to divide times 10,000. And I'm going to do that on this side. Now to divide by 10,000, all you really need to do is get rid of the well, get rid of the zeros is what it is. So you aren't getting rid of the 2, getting rid of the zeros. So it's going to end up being 1.92. So you're moving everything over. We could do this as a division problem if you wanted to, but it you know, get a calculator if you want. 19,200. It's going to be 1.92 though. So just move your decimal points over. So I got 3 zeros. I move the decimal point over here to here. All right. So let's just show it here. 19,200 divided by 10000, enter, and you get 1.92. Okay. Now, so this is 1.92. And that equals, now this is going to cancel here and here. So it's going to equal 1 plus, and let's move this over because I've got to drop a natural log here. 1 plus 0.0475 divided by 2 to the 2t. And of course, what do I want to do? I want to do the natural log. So I'm going to do the natural log on both sides so that I can move this power over here, right? So I'm going to rewrite this now as natural log of 1.92 equals 2t times the natural log of 1 plus 0.0475 to the 2. Okay. Okay. So again, I can get rid of everything but the t because all this is multiplied together. Everything's multiplied together. Now this number in here, I'm going to change. Let's figure out what this is. So let's do that first. So this is 1 plus 0.0475 divided by 2. Let's do that with a calculator. I'm going to do 1 plus, and then in parentheses, 0.0475 divided by 2, close the parentheses, hit enter, and I get 1.02375. So I'm going to rewrite, I'm going to take this amount here, and I'm going to put it here, replace this, okay? So I'm going to rewrite this as natural log times 1.92 equals 2 times t times the natural log of, now all this is 1.02375. Now I'm leaving the whole thing, okay? Notice that. I'm not rounding at this point. I don't round till the end. All right, now I'm going to divide. I want to get the t by itself, and I said everything's multiplied together here on the right. So I'm going to divide the whole thing by 2 times the natural log of 1.02375. And I'm going to do that on both sides. So 2 times the natural log of 1.02375. All right, so this 2 and 2 cancel, natural logs cancel, this cancels, and I'm left with t now. So this all is t, and we're going to get an approximate answer. So approximate answer. So I'm going to now figure out what this is in the here by putting it all into the calculator. Hit clear. All right. So I've got in the numerator, I just have the natural log of 1.92, and then the division sign, and then down here I'm going to have to put this stuff in parentheses in the denominator. So natural log of, and then 1.92, close that, and then put my division sign. And now I'm going to go to the denominator, and this is going to be 2, so I'm going to put this in parentheses, 2 times the natural log of 1.02375. See if I wrote that all right. Close the parentheses. And let's cross our fingers that we did it right. Nope, I missed something here. Let's see, what did I do? So natural divided by 2 times natural at 1 point. They probably want us to throw parentheses around the whole thing. So in the denominator. Let's try it again. So natural log of 1.92, and then divided by the denominator. So I'm going to put parentheses 2. No, let's not do it that way. I want to do double parentheses. So again, I'm going to type in natural log of 1.92, okay, divided by, and then parentheses, and then another parentheses, 2 parentheses, natural log of 1.02375, parentheses, close the argument, parentheses. Okay, so I get 13.895. Okay, we were rounding nearest to the nearest tenth, so it's 13.9. Okay, so this answer is approximately 13.9 years. Okay, all right. Believe it or not, we have one more. Okay. So Gavin invested $350 in an account paying an interest rate of 4.7 compounded continuously. So if remember, this is the famous PERT formula when you're doing continuously. So if you remember the PERT formula from our earlier log apps lesson, that formula is area equals principal to a base of E to the rate times time. That's in the exponent. Okay, so invested $350. So this is your principal. This is P. Okay, let's move this down. And then in an account paying an interest rate of 4.7%. So again, change this to a decimal. So your rate equals 0.047. Okay. Compounded continuously, we said. So assuming no deposits or withdrawals are made, how long would it take to the nearest tenth again? So long, of course, that's the time, right? T, find T. For the value of the account to reach $890. So this is my Y, or A rather. This is my A. Okay. All right, so that's my A. So I'm going to write this as $890 equals my principal of $350. Let's move this down just slightly. So $890 equals, let's let's not get sloppy, equals 350, and then to the e, and then the rate we said was 0.047 times time. Okay, so there we want to get this all by itself. If this is your exponent, we need to drop some natural logs in front. Natural log, so that we can bring down your exponent in front and multiply it to everything. So I'm going to rewrite this as the natural log of 890 equals, oops, did I? What did I do wrong here? Oh, the 350. Yeah, okay. No, I haven't done anything wrong yet, but I need to get rid of the 350. Let's just write this down now as natural log Let's stop a second. Let me go back just a step here. Let's get rid of the 350 here before we go into the natural log mode. So I'm going to divide by 350 on both sides. So I'm going to end up with the natural log of 890. Oh, and what is 890 divided by 350? It's, you just drop the zeros. It's 89 divided by 35. So natural log of 89 divided by 35 equals the natural. Okay, now I've got the natural log. Let's drop down the exponent. So 0.047 t times the natural log, and then of course this is canceled. So it's the natural log of e. Okay. All right. So now I want to get the t all by itself. So I want to get rid of, remember all this is multiplied together. I want to get rid of the the 0.047, and I want to get rid of the natural log of e. So I'm going to divide by 0.047 times the natural log of e. Let's see, do I want to do that? Maybe I just want to get rid of the let me think a second here. Oh, remember the natural log of e? This is actually, natural log of e is the log of e. So natural log of e is actually the log of e to the e. And what power, this is the base, what power do you need for a base of e to come up with an output of e? The only answer is 1. Okay? So this becomes 1. So let's just change this to 1 up here. This becomes 1. All right, so now that's 1. Then we don't need to worry about it anymore. So let's just divide out the 0.047, and I'm going to divide all this by 0.047. Okay? And so 1 times t is t. So I have approximately t here. Now I'm going to go ahead and put this into my calculator on the left-hand side. And so I've got the log of 89 divided by 35. I could do that easily without any parentheses other than what goes into the log itself. So I'm going to type natural log button, and then I'm going to put in, oops, I got to turn it on first. So natural log button, and then 89 divided by 35. Close the natural log, and then I'm going to divide it by 0.047. and hit enter. And I get 19.857. We're rounding to the nearest tenth, so that would be 19.9 years. Time is 19.9 years approximately. Okay. So that's it. That is all we are doing for today. And I thank you very much, ladies and gentlemen. Hopefully this will help you. I'm probably going to extend some time to allow you, since I kind of I got this late. I forgot about it, to be honest with you. And so I want to make sure that you get a fair shake as far as your test is concerned. So I will talk about that in class. In any event, have a good one, and we will see you. Thank you very much. We'll close.